Hello, my name is Eldridge Alexander, and I'm going to be speaking to you today about the ongoing encryption and centralization of DNS. I currently work for DoH Security in a section called DoH Labs. So before I dive in to the ongoing encryption and centralization of DNS, I want to talk about how we got from there to here, why this is a relevant topic today. So Paul Mockapetris and John Postal created DNS in 1983. This was made in an effort to replace the previous way of communicating host names across the internet, which was distributing a hosts.txt file to every host on the internet. As the internet grew, this became unwieldy and cumbersome. So these two engineers wanted a way for people to be able to access hosts by name instead of IP address without having to distribute a hosts.txt file across the entire internet. So they created DNS. And in the beginning, and up until very recently, it was unencrypted. And even today, the vast majority of it is unencrypted. So why? Any new protocols or systems that we start working on today, it's generally something that is considered very early on, is how are we going to secure this, or how are we going to encrypt this? And the reason was multifold. In the early days of the internet, security was not as much of a major concern. There were less hosts, there were less complex threats, there were less actors on the internet. Not only that, but as you can see from Dr. Mockapetris' quote here, a distributed system was already an uphill battle, convincing people to adopt it across the entire internet. So making it more easily adoptable was a crucial point of the creation of DNS. So why is this relevant now? DNS was created in 1983. Now, 37 years later, why is DNS encryption a relevant topic? HTTP was invented in '89, started rolling out in the early 90s, and we started encrypting HTTP into HTTPS much, much earlier. So why has it taken us 37 years to go from an unencrypted to an encrypted protocol if it's something that we need to do? So this is where I'm going to start diving into some of the history of why this became a relevant point of conversation. So first I want to break down a simple web request from an average consumer. So this is a picture that you might see in the web in the early 90s. It's a diagram of what might happen on the web in the early 90s. So first, the endpoint sends a DNS query to a DNS server. The DNS server responds with the IP address. The endpoint then sends its HTTP GET request to the web server by IP address, which then gets the response. So everything in the green box is sent in the clear. In the early 90s, DNS was, as it is today, by and large unencrypted, and HTTP was just HTTP. HTTPS wasn't really on the scene yet. So everything was in the clear. A middleware, whether human or robot, malicious or benign, sitting in between the endpoint and either of those servers would be able to read everything that crossed the connection. So this was one of the things that started out being widely adoptable, this being the web and HTTP, started out being widely adoptable and adopted by people across the entire internet. Not only that, but the web started absorbing other protocols into itself. So while other protocols still might exist, generally most people will access those protocols through a web interface. So a couple of examples are email. Even though a lot of the email protocols still exist and a lot of email communication still happens through protocols like SMTP, POP, things like that, most end users today are going to be receiving and writing emails through a web client, even if the back end of that web client is communicating using something other than HTTP. Chat communication protocols, XMPP, which is great, started being accessible through web interfaces, whether through an aggregator like Meebo or through a particular provider's implementation, such as Google Chat. Transferring files, that's something that the protocol isn't even quite as relevant anymore. FTP is still around and it's still used, but many people for transferring files to friends and family and colleagues are using online data sharing tools such as Google Drive or Dropbox. Even today, more and more protocols are being moved to the web. Video conferencing tends to happen, if not always in WebRTC, tends to be broadly supported across the major video chat platforms. And even other protocols that do not have a web equivalent are quite often wrapped in WebSockets, depending on implementation. So in the beginning, we have this new protocol of HTTP. It's sent in the clear, the same as the DNS query, and it's so successful in the internet world that it starts absorbing other protocols into itself. So let's fast forward to 2015 to 2020. This is Google's transparency report. So you can see in the last 5 years, depending on platform, people have gone from accessing sites from a little under 50% to over 90% on average, accessing sites in HTTPS. So most things have been absorbed, most communications across the internet have been absorbed into HTTP, and HTTP has mostly shifted to HTTPS. So again, these are broad trends. They're not indicative of everything happening on the internet, but broadly, this is a good picture of what an average endpoint or an average user is going to be doing. So let's jump forward a little bit. We've got this early 90s picture of a DNS request and then an HTTP request. As HTTP starts shifting to HTTPS, this is no longer all sent in the clear. DNS stays in the clear, but HTTP shifts to an encrypted model. So anyone sitting in the middle, human or robot, is not able to intercept, data aggregate, or manipulate the data passing in the HTTP connection to the web server. So this was one of the first things to go dark, so to speak. And then some other things happened. One of the first was reverse proxies and cloud computing became more popular for delivering services. So in this example, the destination IP address was actually a pretty useful piece of information. If a person was sending a packet to an IP address, even if the contents of the packet were encrypted, the IP address itself was a pretty useful bit of information. If the IP block was owned by, for example, Stanford University, you could probably make a decent assumption that the person was going to a site owned or operated by Stanford University. As more and more sites and services moved to either cloud computing, for example, DigitalOcean Rackspace, Google Cloud, Microsoft Azure, Amazon Web Services, or they used those services or not, but protected them by CDN networks such as Cloudflare or Fastly, the amount of IP block owners that people were actually accessing became very narrow. Almost no matter what site folks are going to on the internet, they are going to be going to an IP block owned by one of these small number of providers, even if the end server is not actually hosted on those providers. For example, my personal website hosted on a Raspberry Pi is out of my home, but the IP address you'll be hitting is Cloudflare. That's the reverse proxy. In this diagram, the web server is running on my home IP, but the only IP address you'll see is the one owned by Cloudflare. So not a particularly useful piece of information, because while I could be going to my site, you can't see the contents. I could very well be going to one of the many other properties behind those reverse proxies. So the IP address became less of a useful piece of information. The contents of HTTP was opaque to any middleware. The connection to the end web server is probably encrypted. It is in the case of my site, but it doesn't really matter because the middleware is sitting between the endpoint and the reverse proxy, not the reverse proxy and the web server, at least for the purposes of this example. So the reverse proxy is not just going to one site, it's going to many, many sites now. So the IP address is no longer useful data to gather, at least not extremely so in most situations. Now, I want to go back a bit and correct a minor thing that I said earlier and explain it a little bit more. Because the IP address was actually useful information in the early days of the internet, in the early days of the web, the fact that someone knew the host name was not that you were trying to go to was not a particularly egregious oversharing of information, because there was a close to one-to-one mapping between IP addresses and hosts in the early days of the web. So the TLS handshake that is used to establish the HTTPS connection sends the host name, for example, google.com, in the clear using a SNI, a server name indication. So this is sent in the clear before the HTTPS tunnel is established. So while the IP address was useful, this was not really a huge problem because you could derive that data fairly accurately anyway by gathering data around the IP address. Today, with the reverse proxies making that data particularly useless, the fact that it is sent in the clear in the TLS handshake in SNI is actually a problem because it's sharing data that is not easily inferable from any other place in the HTTP connection. So TLS 1.2 and predecessors do send this in the clear. TLS 1.3, which is starting to see wider and wider adoption, is replacing this with an encrypted version. So the entire HTTPS connection, including the hostname sent in the handshake for TLS, is now something that is completely opaque to middleware. So, looking at middleware through the years, these are the things that it particularly found useful. And again, middleware meaning human or robot, malicious or benign, could infer data about you or manipulate data going to your endpoint by intercepting the DNS query, the destination IP address, the contents of the HTTP connection itself, or the SNI in the TLS handshake header. That was at the beginning of the web. Today, most of this is going away or has gone. So the DNS query is the last relevant piece of information in establishing a web connection that actually tells where the user is going. So why is DNS relevant now? Why is DNS encryption relevant now 37 years later? It's basically the only thing left in establishing a web connection that is unencrypted and still shares relevant information, namely the destination host. Now, I want to take a small side tangent and talk about middleware. I've been saying middleware, human or robot, benign or malicious. This has been a continuous discussion point with my colleagues and my team and my friends. What is the concept of a benign middleware? This was something that I personally struggled to really wrap my head around. As a privacy and security enthusiast, I thought that, okay, hey, if you're going from A to B, then you should go from A to B, and nobody in the middle should be able to intercept it. And I was trying to figure out what reconciliation or what reason there might be to have a proxy that was actually a good reason to have it. So I spoke with my friend Jordan Wright, who's my colleague, and he gave me some really good examples to contrast with the malicious examples that I had seen in my career. So these are pretty well one-to-one maps. It's the same technologies being used for benign and malicious purposes. So the first one is visibility. If you have a large corporate network or organizational network, you need to do effective defense, be able to see what your endpoints are doing, what your users are doing. Not just visibility, but if you're able to manipulate the traffic itself, DNS or otherwise, malware blocking is a huge opportunity for middleware to be useful to organizations. Not only that, but data loss prevention. If you're able to monitor, establish, and even prevent in some cases DNS queries from being responded to or being responded to accurately, then you are able to prevent data loss in a lot of scenarios that you might not otherwise be able to. So now the equivalent technologies on the malicious side are non-stakeholder data aggregation. So what's visibility in an organization monitoring the DNS of their enterprise devices, accessing enterprise networks with enterprise data, for an end consumer using their laptop to access consumer sites on the internet, that data aggregation is providing visibility, but it is not providing any benefit to the stakeholder of either the content provider or the end user. Malware blocking is effectively just lying about DNS responses. Use the DNS request for a host name that is known to present malware to its users. Your enterprise middleware will lie and say, the actual address of this site is 0.0.0.0, or redirect you in some other mechanism to a non-malware site that can communicate with you. Response alteration in malicious ways can mean a few different things. The most common example is if you are on some internet providers and you go to a page that does not have a DNS record, or you attempt to go to one. What should happen according to the standards and specifications is you should receive no response from your DNS server or a non-resolvable response. that your browser can then use to show this page is unavailable. What often happens is you are returned a response that redirects you to a page full of ads that financially support the internet provider that you're already paying. So that is something that I personally would consider malicious. Not only that, but reconnaissance. If you're just sitting in the middle, gathering data in middleware, you can use that to launch a more targeted attack as you learn more about your targets. So the differences between benign and malicious are certainly somewhat opinionated. There are some people that will hold the opinion that any interception between points A and B is inherently malicious because it's breaking the guarantees of encryption from one place to another. There are some people that will say all of it is benign because it's on behest of the network operator. Most people, I think, come to some understanding approximately what I'm showing here, which is that some of these have benign purposes, some have malicious. So now I want to jump back to DNS. So we know that in the last 37 years, DNS has been broadly unencrypted, but it is now becoming a more relevant talking point because it is one of the most relevant points to gather and manipulate data benignly or maliciously with endpoints. So I want to talk about the new standards that are being proposed and adopted across the industry today. I put DNSCrypt on here. This is one it's a pretty good standard. The team has done really great work in making it, but it's not one that I personally am seeing broad adoption across multiple vendors in the industry, endpoint or DNS server-wise. So I wanted to highlight it here because it's pretty cool, but it's not one that I'm going to be spending a lot of time on today. So I want to talk about DNS-over-TLS, DOT, and DNS-over-HTTPS, DoH. These are the ones that I'm seeing have broad adoption in the industry. So the old concerns of DNS are kind of what I've highlighted about middleware. Now that we are encrypting it, we are presenting new concerns because we have both this malicious and this benign middleware, and this benign middleware is affected. So what are these DNS concerns? Well, the first one is centralization, the second, reduced visibility, and the third, DNS in layer 7. That's the most unprecedented one that I want to spend a little time on. But first, let's dive into centralization. Now, this is, in my view, a pragmatic reality of changing such a fundamental protocol on the internet. It's not something that's necessarily inherent to DoH or DOT. So as providers start enabling and supporting DoH and DOT, because there's such a focus on privacy and security in and outside the industry right now, providers supporting these new encrypted protocols are able to get a lot of sway and get a lot of support from end users. So while there are lots and lots of DNS systems and servers out there, that's the point of a distributed system, only a few providers in the early days of DoH and DOT were providing encrypted DNS. Notably, Google, Cloudflare, and Quad9 were some of the earliest to support these encrypted protocols. So out of the thousands of DNS servers on the internet, if you wanted to use encrypted DNS, you were mostly relegated to a handful of providers. Now, in my opinion, they did fairly good things around privacy and security, but it was a centralization of what had previously been a distributed system, or at least a centralization for those that wanted to use encryption. So this was more pragmatic reality, not something inherently a problem with DoH and DOT, but the centralization of a distributed system is certainly seen as a problem by many, myself certainly included. So another concern is reduced visibility. And this is something that applies mostly to the benign middleware I was speaking about a few minutes ago. The ability of end users to send their DNS requests over DOT or DoH prevented the ability for enterprises to monitor their DNS requests. It prevented DNS redirection, which is a really useful feature for places that are deploying, for instance, IoT devices. A common feature in network firewalls and other network security devices is the ability to take an outgoing DNS request that, for example, is using a hard-coded DNS destination and redirect it to your corporately owned DNS server and send that response back to the device transparently to the device. So if you have a handful of IoT devices that are using their manufacturer's DNS server for whatever reason, and you want to block certain requests they're sending. If the DNS is unencrypted, you can of course still do that even if they're sending their requests to a DNS server that is not owned by you. Also, DNS is a control plane. If you're attempting to block malware or restrict DNS queries that respond with domains that you know to be bad, then you can no longer do that if the DNS is leaving your network in an encrypted fashion. Now, there are a couple of other mechanisms you could do. In a lot of times, if there's a protocol that's providing problems with you, you can just block the ports of that protocol. That will, of course, not stop someone from changing ports, but it will stop the vast majority of end users. DoH makes this particularly problematic because you can't really block an HTTPS connection wholesale, nor could you probably effectively block an HTTPS connection to some of the most major providers like Cloudflare and Google, as blocking HTTPS connections to those destinations would provide a lot of pain for many things other than DoH. And then the third major concern I want to talk about, and this is the one that I personally am most concerned about of the three, is moving to the application layer. So as DoH and DOT has become more broadly adopted across the industry in privacy and security circles, it has not been as broadly adopted by the plethora of DNS servers that are out there. So slow inroads at operating system levels, it's also not been broadly adopted by operating systems such as macOS, Windows. So vendors that are very concerned about their end users' privacy and have a consumer-centric worldview, and the most potent example here is Firefox, caused these application developers to bring in their DNS resolution from the operating system into the application itself. Now, that's a tough trade-off to make. In my opinion, for something that is consumer-focused in the current landscape, it did make a decent amount of sense and was an okay trade-off. There were new laws in various countries passed that meant that providers intercepting DNS queries were able to aggregate and sell personalized data. So for an organization that is mostly concerned with end consumers and mostly concerned with protecting the privacy of those consumers, if the operating system was not going to enable this new privacy protecting measure, then bringing it into the application layer was a compromise that made sense. However, this does mean that the DNS server issued by the DHCP server is not going to be respected by the application. So this is a problem for all of the aforementioned reasons, as well as making a new point where data can leave the network, or DoH can leave the network possibly transparently to network operators. So while this was a major privacy win for consumers, in my opinion, this was a security loss for network operators that were trying to operate benign middleware. So what are the next steps? What are the next steps that we can take as an industry to address these concerns, get the benefits of adding encryption to a very important protocol on the internet, while minimizing the problems and the concerns with that as much as possible? One of the first is just integrating more operating system support and more provider support across the entire industry. This will mitigate centralization directly. Again, centralization is a pragmatic reality, so if more and more systems and services are supporting it, centralization will no longer be a concern. Reduced visibility will be another one. If your endpoints support DOT and DoH natively, and your middleware and services support DOT and DoH natively, then reduced visibility won't be a problem because you'll have visibility in the same places that you used to. What these two will not directly mitigate is the pulling of DNS into the application layer. However, it will disincentivize browser vendors and other software vendors from pulling it into the application layer, at least with such opinionated defaults, as they can rely on other pieces in the stack to do what they consider to be the right decision. So to that end, I'm going to be demoing my software that I'm calling Vimes. And so I'm going to drop into a demo here. First, to just give an explanation, what this is meant to do is, unlike some of the DNS encryption proxies that exist on the market today that send to those centralized providers, this tool will look at the DNS server that your system is using by default, almost always on an endpoint, because you have received that from a DHCP lease. it will test it to see if it supports DNS encryption, and then opportunistically upgrade your DNS connection, but still use the DNS server that your system is wanting to use. So I'm going to jump into the video here. So first off, I'll draw your attention to this is a pretty simple and not super flashy demo, which is, I think, good. If you're having flashy demos around DNS, something's probably horribly wrong. So this little green bubble here is where we're going to focus on. It's going to change colors. Let's have a look. So you can see here that I am connected to the Xfinity Wi-Fi hotspot, and so I'm using Comcast's DNS server, 75.75.75.75. Now I'm going to go to, sorry about that. So I'll go ahead and explain what the next part is going to be. So I'm on Xfinity Wi-Fi, and I'm going to go to 1.1.1.1/help, which is Cloudflare's DNS status page for how you're connected to their DNS. And so I'm going to show that here. So I'll pause the video here. You can see that it's showing that I am not connected to Cloudflare's 1.1.1.1 DNS service, and I'm also not using encryption to their service because I'm not connected to it at all. So you can see that the Vimes icon in the system tray there is red, indicating that I am not using a DNS server that supports DNS encryption. I should also make a side note and say that at the time this video was recorded, that was the case. By the time you're watching this video, I believe Comcast will actually support DNS encryption due to a recent announcement. But let's jump back in here. I'm going to switch to my Eldridge guest network, which issues 1.1.1.1 as the DNS server via DHCP lease. So what's going to happen is Vimes is going to let the Wi-Fi connection happen and then run a test, and you'll see that Vimes has shifted to a yellow indicator. What this means is that you are using a DNS server that supports DOT or DoH, but your operating system is not taking advantage of that, which is the case, as I mentioned earlier, of pretty much every operating system on the market today, desktop ones. So what we'll do is we'll refresh this status page, and you can see that we are connected to 1.1.1.1, but still not using any of the encrypted protocols. So now what you can do is just click the Vimes icon. That is going to do a couple of things to enable encrypted DNS, which I'll dive into in a second here, but we'll refresh this page again, and you can see that the Vimes icon is turned green to show that we are using encrypted DNS. We are connected still to 1.1.1.1, so we are using the DNS server issued by the DHCP lease, but we are using DNS-over-TLS. So what Vimes is doing in the background there is it's spinning up a core DNS server locally on the machine. Core DNS is a pretty efficient DNS system written in Golang, used in Kubernetes. So it's spinning that up and redirecting all DNS queries to it, which it's then wrapping in DNS-over-TLS and sending to the original destination DNS server. Cool. And that will be open sourced later today, if not already by the time you're watching this video. So I want to list a few updates that have happened since I submitted and prepared this talk. So when I submitted this talk about 2 months ago, if I'm remembering correctly, the only platforms that natively supported DOT or DoH was Android 9 and above, which was a minority of the install base of Android. In the last, I believe, 4 weeks, support or announced support has happened for all of these things. So Android 9, Windows 10, macOS, iOS, Firefox, and Chrome. So while Vimes will be useful until these move their native implementations to stable, and it will be useful for places that can't necessarily upgrade to the latest versions, hopefully in the coming months, you'll be able to do this natively in your operating system rather than relying on an add-on. Also, I did want to highlight, this is not a comprehensive list, but other tools, services, and systems in the industry that are supporting DNS over TLS and DNS over HTTPS. Curl has been supporting DoH for a while now. Comcast and Cox have now announced that they are going to support either DoH, DOT, or both. Hurricane Electric, Cisco Umbrella, Core DNS, which is what I'm using in Vimes, and Quad9 are supporting DoH and DOT. So let's wrap up and kind of hit my conclusions here. So DOT and DoH removed some of the concerns around malicious middleware, added some concerns around benign middleware. These new concerns are not necessarily entirely new, but they're a move of where this functionality, where this benign monitoring and manipulation has to happen, since it can't happen transparently in the middle anymore. And the benefits, in my opinion, of DOT and DoH can be realized without sacrificing the control that benign middleware operators have, as long as the legacy approaches are modified and adapted. So that was the ongoing encryption and centralization of DNS. Again, I'm Eldridge Alexander with Duo Security, and so I am now going to take questions. This is Video Me, and Live Me will be taking the questions. So Video Me, handing off to Live Me. Take it away.
Thanks, Video Me. So I'm going to go through the chat here. Feel free to post some more questions as they occur to you. But I'm going to go through several have already been posted. So first from Jim Reed, what challenges does DoH mean for ISPs and enterprises that currently provide DNS services? What could or should be done about that? So I saw you posted that earlier in the talk, so I hope I touched on it a bit. But the challenges I see primarily for ISPs and enterprises are those using DNS as a control plane, being unable to gain visibility or apply security policies using DNS as a control plane, unless they get all of their endpoints to use supported encrypted DNS protocols, as well as upgrade all of their servers. If both the endpoints and the servers are using new encrypted DNS, then the challenges are pretty much non-existent for the enterprises. I probably shouldn't say non-existent, but become very minimal for the enterprises. ISPs, kind of the same deal. If the ISPs are supporting encrypted DNS and the user endpoints are, then same deal. The problem you're going to run into here is if ISPs are running, for instance, interception or security policies on plain text DNS that's going to a DNS server that's not provided by the ISP, but the ISP can sit in the middle and change that. I haven't really seen that in the wild. The closest I've seen is if you're on AT&T Uverse and you go to a website that doesn't exist, instead of them returning back a DNS no record exists error, they'll redirect you to an AT&T ad site. So as long as both the endpoint and the server support it, I'm not seeing a whole lot of challenges for enterprises that want to support it. The challenge is, of course, as I think you touched on in a later question, as applications like Firefox and even Chrome start to support it natively, that DNS might be happening that they're not even aware of because it's going over DoH. So I'll go through the other questions, but I'll touch on that too in a second here. Next question, also from Jim. What's the privacy win for users if all their DNS queries go to a major DoH provider? None. That's probably a bit too reductive. My hope, and one of the reasons I wanted to talk about some of this stuff here is the centralization is not an inherent property of DoH or DOT. It's DOT. It's not even really a practical reality. It's just a bunch of big providers, Google, Quad9, Cloudflare, supported it early on. And so anyone wanting to use encrypted DNS was centralized on those providers. As the protocols become more supported, and as I mentioned in my update slide, it's being supported by Windows and the Insider Ring now, and Apple announced it for the next versions of macOS and iOS. Comcast and Cox are announcing it. Curl and other open source tools are starting to support it. We're hopefully going to see greater dispersion so that we'll end up with something very similar to the original distributed system, just with point-to-point encryption. But yeah, you're absolutely correct. If that doesn't play out like I'm anticipating, if it really does stay that only a few servers and only a few service providers are supporting this, then yeah, we absolutely will not have an inherent privacy win. Obviously, there's the potential for a privacy win if we have a bunch of these distributed systems that are behaving maliciously and we move to a few central providers that are behaving benignly, but that is more optimistic than I'm willing to commit to. So from James Kennedy, I hope I'm saying that right. What about aggregation and manipulation by the DOH providers, effective monopolies? I think that's a similar question. There are lots of advantages in having distributed servers. And so I think if we end up with the reality of just a few providers that have manipulated the environment by supporting DoH and DOT early, that's going to be problematic. Like I said, I think Google and Cloudflare and Quad9 have been doing a good job so far, but I think you don't want to concentrate power to the handful of a few service providers in what's an inherently distributed system. So yeah, absolutely. If they start to consolidate, if we start to consolidate more and more on those service providers, that's a problem. I don't think them having a plurality of DNS requests on the network on the internet is a problem, as long as there are enough alternatives out there and those alternatives support encryption. The thing that I think would be very bad is if your options are either use an unencrypted service that allegedly protects your privacy or use an encrypted service that probably doesn't, because then you're going to get into all of the privacy concerns around, okay, maybe the DNS provider you're using is fine, but it's unencrypted and you're sending your connection through Comcast or AT&T or another provider that, so now you're expanding your attack surface, your privacy attack surface. Let's see. Gregory, have standard internet protocols been updated to allow for encrypted DNS? I don't know that I quite understand your question there. Sorry, if you want to provide clarity a little bit, I'll try and speak to it. By standard internet protocols, yeah, I'm sorry, I'm not sure. If you're speaking to like TCP or UDP, they both, of course, one thing I didn't really touch on in the talk is DNS was primarily over UDP unless the response was too big. DOT and DoH are inherently mostly TCP-based protocols. Of course, it's conceivable that DoH would eventually move to QUIC, which is a UDP-based protocol, since HTTP3 is going to be over QUIC. But that's, sorry, I'm going off on a tangent here. So yeah, but it's all the actual query itself is going to go over either TCP or UDP, and the upper level protocol is going to be either TLS or HTTPS. So yeah, and then of course any other application in the stack is just going to get the response as it would normally. So yes is I think the answer to your question, but if you want to provide clarity, I'll pick that up as I go down the list here. From Narendra, how is the PKI working with HTTPS TLS when doing the initial connection to DNS server without the hostname for the certificate? So you do need to provide a hostname when you're configuring those for the first time. There are some options, of course, for major providers. You'll be able to reconcile the IP address back to the host relatively easily. 1.1.1.1's Cloudflare, 8.8.8's Google, 9.9.9.9 is Quad9, 7.5.7.5 is Comcast, etc. If you are configuring one that's not in the list of common providers, then yeah, you absolutely will have to configure the hostname manually, which you'll see if you configure either DOT in Android 9 Plus, or if you configure DoH in Firefox, you'll see that you have to put in a hostname. DoH looks likely to bring about the consolidation, sorry, from Jim again. DoH looks likely to bring about the consolidation and aggregation of DNS servers into a few number of players, chosen by browser vendors and killer apps. Why do you seem to disagree with that opinion? Is the centralization healthy for both user privacy choice and market competition? It's absolutely not healthy, but I do disagree with that opinion. I think that it had an early consolidation effect because there were so few people on the market that supported it, and there were so few people on the market that supported it because it didn't work on Windows, Mac, Android, unless you were on version 9 Plus, which was a small, or iOS. So I think as operating systems start to support it, you'll start to see vendors and providers and less major DNS providers provide it. I'm scrolling through, I've got about 45 seconds left. Gonna see, let's see. All right, I am coming up on time, and I don't think I can speak to any of these questions effectively in 20 seconds. I will stick around in the chat for a few minutes afterwards and try and speak to them as best I can. Feel free to follow up with me there. I also have open DMs on Twitter, or feel free to reach out to me at eldridge@duo.com or gif@cisco.com. Yeah, so thanks so much for coming by, and everyone enjoy the rest of Black Hat.